Hi, Professor Baldwin here, and today we're going to factor binomials. Remember that binomials are polynomials that have two terms. The polynomials or binomials that we're going to factor today are the difference of two squares. So the first term is something squared, and we're subtracting from it the second term, which is also something squared. And that factors into these two binomials. One where we're subtracting those two terms, and the second where we're adding them. Extra important, the sum of two squares. When you see a squared plus b squared, this cannot be factored with real numbers. And these we're just going to write are prime. They can't be factored. So let's look at a few examples. Remember, whenever you're factoring anything, your first step is to always identify if you have a GCF or not, and to factor that GCF out. There's no GCF in example 1, so to identify if we have a difference of two squares, we're going to look that the first term and the last term are things being squared, and we're going to verify that we have subtraction. Well, our first term is something squared, it's x squared. Our second term is 9, which is 3 squared, and we're subtracting. So we have the difference of squares. Our a and our b here are x and 3. So this factors as x minus 3 times x plus 3. Look at example 2. Same steps. Do we have a GCF? We don't have a GCF. Is 16 something squared? Well, 16 is 4 squared. What about the second term, 49w squared? Well, the w is being squared, and 49 is 7 squared, so this is equivalent to 7w squared. And we have subtraction, so we have a difference of two squares. Remember, this factors into the two binomials. We have 4 minus 7w and its conjugate 4 plus 7w. Let's look at example 3. Do we have a GCF? No GCF. Is our first thing something squared? It is. It's w squared. And our second term is 4, which is 2 squared. But look at the sign in between. It's plus. So this is a sum of squares. And what did we just learn about a sum of squares? A sum of squares can't be factored with real numbers, so this binomial is prime. We can't factor it. So let's look at number 4. Do we have a GCF? We do. We have a GCF of 5. If we factor that GCF out first, we have y to the 4th minus 1. Okay. Do we have things that are squared in here? Well, let's see. Let's keep the 5 on the outside. We're going to put some brackets now. Y to the 4th, well, that's the same as y squared squared. And what about 1? Well, 1 squared is still 1. That's one of our sneaky values, 1. 1 squared is always 1. So we have a difference of squares here, the y squared and the 1. So inside of the brackets, we have y squared minus 1 and its conjugate, y squared plus 1, for our difference of squares. Are we done? We're not done. Look at this first binomial inside of our parentheses. We have y squared and we have 1. And I just told you 1 is sneaky. This 1 could be 1 squared. As 1 squared, we have another difference of squares here. So we can keep on factoring. we have our 5, our GCF. I'm going to rewrite this difference of squares as y minus 1 times y plus 1. And then this very last binomial, y squared plus 1, that's a sum of squares, and we can't factor that, so that one stays. Now let's check each of our terms again. Each factor is good. We don't have any more that can be factored, no more hidden difference of squares. How about a couple more examples? Here we have our variables in the second term instead of the first. That's okay. It doesn't matter. We just need to identify what is being squared. In the first example, we have 25, which is 5 squared. And our second term here is 49q squared. Well, q is being squared and 49 is 7 squared. So that second term is 7q squared. And we have subtraction, so we have a difference of squares. And that factors as 5 minus 7q and its conjugate of 5 plus 7q. Okay, look at example 2. 1 minus 25p squared. Well, we have that sneaky 1 again. Remember, 1 is the same as 1 squared. So we have 1 squared, and then we have 25p squared. 25 is 5 squared, so we have 5p squared. And we have subtraction, so again we have a difference of squares. And that factors to the binomial of 1 minus 5p and its conjugate 1 plus 5p. Remember, you can factor the difference of two squares. You just have to identify what is being squared in the first term and what is being squared in the second term. You cannot factor the sum of squares. So if you see a plus sign between those two terms, you can't factor it. Thank you for watching. I hope you found this video helpful, and I hope that you'll check out some of my other math videos for more help.